Do you struggle with cooking meat? Maybe you're overly cautious and cook your chicken as black and dry as you can to avoid getting salmonella. Or maybe you accidentally cook your chicken as raw and rare as you can to make sure you don't lose any of those coveted meat juices. Or maybe you just don't have the time and concentration to cook meat, but you still want a professional quality meal. Well, look no further. A smart meat thermometer has arrived. Whether you're the sous chef or the choux chef, our avant-garde meat thermometer provides innovative features and state-of-the-art calibration to ensure that everybody, including you, can cook meat like the pros. At last, the future of cooking meat has arrived.
Oh wow, it's good. Oh wow, that's very tasty. Yeah. Oh wow, the second piece. Oh, that doesn't mean a guaranteed A though. It just means I'm having a second piece of chicken. Oh, that's good, guys. Done with lunch.
You're gorgeous.
You should order for everyone. Yeah, it's good. Are you recording the vocals? Oh, well, too late now.
Yeah. You know we're right.
All right. Thanks, you guys.
For our hardware implementation, we used Lab 6 with the speakers and Lab 7, the thermocouple example. For our ESP to connect to the internet, we use Adafruit MQTT and IFTTT. In IFTTT, we utilize the email and the text message function. We use the email function to let the ESP know what protein and what doneness is desired. We set up two different automations for the text message function, one for the flip message and one for the doneness message. For our code, we first start by entering a loop that exits only when the temperature is changed. How we do that is by this check message callback, which is the same here. First, it decodes the message by looking at what protein, then what doneness the user wants. If not a valid temperature is given, it'll just default to a safe temperature. We then enter the doneness part of the loop. We first start by reducing the flip time by 1 second, then we enter the thermal sensing part of the loop. This is to read the temperature from the thermocouple, and we append those into an array size of 20. The 20 array size is to reduce noise. 15 to 20 works the best. This is to calibrate the thermocouple when we're averaging the temperatures. These two if statements are basically the same. They both change the PW into 50%. They both send different messages for IFTTT. And they both start a timer for playing sounds. Some obstacles that we faced in this project were trying to get 3 callbacks to work at the same time. For example, we had one for the doneness, the flip timer, and the music. And within the doneness and the flip timer, we were trying to implement the callback for the music. This caused multiple issues, and the PWM for the annoying sound was skipping frequencies, like it would jump from 1000 to maybe 1050 hertz, and it was also kind of interfering with the doneness part of it. And we also had trouble soldering the pads. It was giving us false readings due to the bad connection. And IFTTT is slow because we were using the free plan. We often have to request IFTTT to check the feed on Adafruit before we receive the message. The thermocouple is also very sensitive, so even in ice water, we would receive readings from -1 to 1 degree Celsius.